Hello viewers, welcome to Big Boy Physics. In today's video, our topic is from gravitation, and this question I have picked up is from a reputed institute, J Advanced Papers. This question is based on the topic of gravity, and it's based on hypothetical gravitational force. We know that gravitational force is of form 1 by r square, not considering the modern corrections, of course. We are just dealing with the Newtonian mechanics for here. Now, they are saying that in another universe, this force of gravity is conservative but not necessary in a inverse square law form. Okay, so now we have to find the value of x as mentioned in this question, that is 4 into x into m r to the power 4 v naught square by r to the power 5. Here you have to find x, and where r is the distance from B to O. I'd like you to pause the video for and give it a try for 3 to 4 minutes or max to max 5 minutes. Then see the solution. Okay, so let's get started. I'll be presenting two solutions in front of you. First is a basic law of conservation of angular momentum and about applying Newton's laws of motion. I am considering this green point to be the mass O, and this has, I don't know what is the mass of this point O. We are just interested in finding the force. So just let us assume that this point O applies force F as a function of R. Now initially, suppose the point Bob or the point mass is moving with velocity v naught. So I can say that angular momentum will be v naught into 2r, and when it has moved by an angle of suppose theta, suppose it has moved by angle of theta, and this is the center O. Can you tell me what is the new angular momentum? New angular momentum will be same as the old angular momentum, so the velocity must change. Let it be v, which can be written as v into what is the perpendicular distance. Okay, now what is the perpendicular distance? Suppose this be right angle, this is another theta, so this will be 2 theta. So I can say this to be capital R into capital R plus capital R into cos 2 theta. So I can say it to be V into R into 2 cos square theta. Now cancelling R will, and another 2 will get V is equals to V naught by cos square theta. And another point of consideration is that small r is equals to 2r cos theta. Hence I can say cos theta is equals to small r by 2r. And if I simplify it further, we'll get it to be V naught by small r square into 4r square, capital R square, of course. So this is the velocity of the body after certain moment. Now let us assume that this point O applies a force F in the direction pointing from the body to O. Now the radial force that will be acting towards the center of the circle will be F cos theta. I can say F cos theta is equals to mv square by r, capital R, force balance, because the radial acceleration is omega square r dot r double dot plus r double dot. Now r double dot is 0 because it's with respect to the center. So I can say with respect to the center C, suppose this point to be C, with respect to center C, r double dot is 0, but omega square r is finite. So I can say that f cos theta is equals to mv square by capital R. Now cos theta is again small r by capital 2r. Hence we'll get f is equals to 2 into capital R by small r into m by capital R. What is v square? V naught square by 16 r to the power 4 by small r to the power 4. Hence we'll get the result to be somewhat like this: 32 m v naught square by r to the capital R to the power 4 by small r to the power 5, and that's the expression for the force. Hence, they are asking about 4 into x into all those stuffs. So I can say that 4x is equals to 32. Hence, x is equals to 8. And that's the answer. So the answer to this problem is 8, undoubtedly. Now I also said you about the second approach. Okay. Second approach actually involves an equation, that is force can be written as L square by mr square Just a minute. Yeah. So the second approach actually involves the formulation, their formula, that is L f as a function of r can be written as L square by small m into r square into the double differentiation of 1 by r with respect to theta plus 1 by r, right? Now consider this point O to be the center about which the orbit motion takes place, and this is the orbit. Now to characterize this orbit, how will write? Suppose this is angle theta, so I can write small r is equals to 2r cos theta. Hence 1 by r can be written as sec theta by 2 into capital R. So I can say that d of 1 by r by d theta is sec theta differentiation is given as sec theta tan theta upon 2r. Taking the double derivative, that is differentiating this 1 by r with respect to theta again, we'll get it to be sec theta tan square theta plus differentiation of tan theta is sec square theta, so we'll get it to be sec cube theta by 2r. Okay. Now substituting the values, that is sec theta is all those stuffs, like sec theta is equals to 1 by 2r, and putting tan square theta as sec square theta minus 1, we'll get sec theta is 2r by small r into 4r square by small r square minus 1 plus 8r cube by small r cube by 2r. Okay. Now we are interested in finding d2r by d2 1 by r by d theta 2 plus 1 by r. So just 1 by r we have mentioned is to be sec theta by 2r, or just keep it to be 1 by r only. Hence we'll get the result as 8r cube by small r cube into twice, which will come out to be 16r cube by small r cube. So this is the expression d2 of 1 by r by d theta 2 plus 1 by r is given as 16r cube by small r cube. Now you will be wondering that how I got this expression of f as a function of r. Now I actually discussed it in one of my gravitational videos. I'll give the link in the description. You can watch it. Okay. Or I'll be posting the link in the comments if the link in the description is not clickable. Right. Now L is given as L with respect to point O is given as m into v naught into 2r. Now just substitute this m v naught into 2r by mr square, right? And yeah, there will be one missing factor, that is 1 by 2r here. Hence you'll get it to be 8 capital R square by small r cube. Now the factor we have to multiply is L square by mr square. Division is mr square, and multiplying with 4m square v naught square capital R square, we'll get the answer to be 32 m v naught square r to the power 4 by small r to the power 5, and hence 4x is equals to 32 and 8 is the answer. So we also utilize this Binet's equation. This force and r theta relation is also called the Binet's equation. Once I have read about it, that it's called the Binet's equation. So I have used this force r theta relation to find the equation of the force as a function of r also. So that's it for today. Hope you understood this problem and enjoyed it. Thank you. Have a nice day.